Hey everyone, it's Jim
And Charles
from Valves and More, an online vintage tube store. And today in Tube Lab number 242, we're going to talk a little bit about impedance matching headphones. But first, caution everyone, electronics and tube amplifiers can have very high voltages present, which can be lethal. Exercise extreme caution when working around them. Always consult a professional technician when in doubt. Well, we're just about done the build manual for our new OTL kit headphone power amp. Boy, that's a mouthful. Maybe we should just do, the initials, the OKHPA. What's that spell? Nothing. Anyways, I guess.
If anybody has a good idea for a name, put it in the comments.
Yeah. Anyways, I thought it would be interesting to take a quick look at the effect headphone impedance has on the performance of the amp. Now, impedance can be a difficult concept to grasp. A simple way to think about impedance is to view it as electrical resistance in a live circuit. In other words, with all of the electrons in motion. Typically, this is calculated. Sometimes a measurement needs to be taken, and then it's calculated. The main thing, though, is to respect the amp specifications. Okay, well, let's take a look. So, this is the power amp circuit, and like always, we do the power supply on a separate schematic, but we don't need to look at that today. And it's a very, very simple power amp design, and the real heart of this is the 6AS7 6080 power tube that we're using. It's a twin triode, and we're paralleling both halves of the twin triode. And what that gets us is lower impedance, and we'll go over that in just a minute. So it might be fun to start at the beginning. So your signal arrives, goes through a little coupling capacitor. That just makes sure that if we have a catastrophic failure in the power tube and it starts conducting DC on the grid, that it can't come back and blow up a piece of equipment that's back here, right? Because coupling capacitors block DC and allow the AC signal to pass.
It also means that if an earlier stage, like a preamp, is sending DC down there, that we're not going to blow up our power tube.
Yeah, it works both ways. Electricity really, once it's on the wire, it doesn't have a direction. It just has a path. And if that path is the path of least resistance, watch out. Now, of course, we want a low resistance path for our signal. So along we come. You might say, what the heck is that 47K resistor? Well, that's the load resistor. And it also helps bleed off stray DC that might land on the grid. So there's your path to ground this way. And when the AC signal arrives here, it sees 47K as the load. We have a little grid stopper that just helps keep oscillations off of our input grid. Because remember, we're putting a fairly low signal, maybe only a volt RMS, to drive this amp. Could be less, could be more. It could actually be quite a bit more. To get maximum power, I think we're up around, 24 or 27 volts?
Mm-hmm. But at that point, you won't have ears left.
You won't have any of that mushy stuff between your ears left. Anyways, it's always, with power amps, it's always nice to have reserve. And nothing bad comes from having a little bit of extra power. Anyways, we're going to take our signal off of the cathode. That gives us a very low output impedance. Remember, I've used the word impedance twice now. And that's what we're talking about. So we have to couple because we have DC here, and all we want is the AC signal to get across. So we use a really large coupling capacitor, and we'll talk about that in just a minute as to why it's so large. And here's our 1/4-inch jack, and here are our headphones. At least one of them. So, one channel. Okay, now, what happens when we change the impedance of the headphones? Well, you can see that we're recommending 80 to 600 ohms, which covers the vast majority of high-quality cans that are out there, but not the ones that are using planar technology. And planar technology means that we'll have a much lower impedance, typically I think around 30 to 40 ohms, and that requires a different kind of amp to drive it. An OTL amp is as you can see here, there's no transformer coupling, so we're just using a capacitor to couple. Planar type headphones and very low impedance headphones typically need transformer coupling, or will need a solid state output stage.
I mean, you could build an OTL stage for something that's that low, but what you're doing at that point is you're paralleling a whole bunch of tubes or tube sections in order to get it that low.
Yeah, and it becomes less practical, let's say. And we're all about practical amps that are affordable, that sound great. And the minute we get into the more esoteric side of things, if the price goes up dramatically or the complications go up dramatically, we're out, because the vast majority of our kit building customers, they're just not into that kind of thing. And to be honest with you, I don't think a lot of people are. So practical has always been a big part of my life as an audiophile, and I'm trying to bring it to our companies as well. Okay, so this is a really neat plot that Charles made. I did manual sweeps, full spectrum sweeps from 10 hertz all the way up to 20 kilohertz. The audio band is typically considered to be 20 hertz, which is the very lowest of the bass frequencies that you'll typically see in a system. Some really large woofers can get down to 10, even a little bit lower than that. But for a headphone system, I doubt if there's a pair of headphones out there that can handle 20 hertz without a significant drop in output. So when you get all the way up into the higher frequencies, 20 kilohertz, well, nobody can actually hear up that high. Typically, you're going to be somewhere in this range here. I'm right here.
If you're really young, you might be over here.
I don't know where Charles is. In fact, I don't know if we've tested your ears. I know your high frequency response.
I think I can still hear to around 13K.
So you're over here. So old guy, slightly younger guy. But the high frequencies typically in most power amps really aren't an issue. It's the bass performance. If you look at the performance in the high end, here is the -1 dB down point. So that's 2 full lines down. Typically -1 or +1 dB is sort of the gold standard. If you can keep your amplifier or your preamplifier performing inside of that, you're good. Nobody can hear the difference when the volume shifts 1 dB. Now, here's a pro tip for you guys. When you're looking at specifications or graphs, and you're looking at a piece of equipment, and the manufacturer doesn't want you to fully understand what the performance is on a plot like this, they'll go ahead and they'll make the divisions 2 or 3 dB. And they'll use the -3 +3 dB as a reference point. So we have, let's say an amp has performance 20 hertz to 20 kilohertz, plus or minus 1.5 dB. So that's a 3 dB shift from the lowest to the highest, or -3 dB in this case. And 3 dB is huge.
3 dB, I think, is typically considered to be half the volume.
Yeah. So what we normally do is we'll do a detailed breakdown like this. Now, it makes the plot look a little bit worse than it would be if we actually changed this column here over and, let's say, got rid of 0.5 and 1.5. But if you do that, then the resolution changes, and all of a sudden
This looks perfectly flat, and you can't see any detail.
you can't see anything. So watch out for how these things are portrayed. So you want to see this kind of resolution, at least increments of 1 dB. If not, then they're trying to fudge things. They're not actually trying to change the data, they're just trying to change how the data is presented. Haha. So there you go. Okay, so down here we've got 5 loadings. One that's not recommended for this OTL headphone amp, that's 40 ohms. 40R is just a quick way to say the resistance is 40, right? So that's why you'll see R used quite often instead of the symbol, or writing it all out. It's becoming more and more common these days. Everybody understands it. 80 ohms is the minimum that we recommend. 150 ohms is very common for a lot of high-quality headphones. 300 and 600, a little less common, but there are cans out there with that much load resistance, load impedance, sorry. So let's look at the really good one, 600R. Well, you can see that we're almost dead flat, and when we really start to roll off is somewhere around maybe, I don't know, 17 hertz. That's absolutely excellent performance. We don't even reach the 1 dB down point at 10 hertz, which is fantastic. How about 300R? Well, our load impedance is dropped in half, and our performance has a little bit less good. I was listening to somebody talk about speaker specifications, and he said, I'm going to try and build something that is comparable, but just a little bit less good. I thought, okay, well, I mean, it is. 150 ohms, how about that? That's actually one of our reference pairs of headphones. Sennheiser makes them. They're wonderful cans, and they're reasonably affordable. I think we paid about $600 for them.
And it's one of the more common impedances for high impedance headphones as well.
Yeah, so you can see here the performance is pretty much, even though you can see these lines at this resolution, this is pretty much flat all the way across here. But you can see it rolls off just a little bit sooner. So where's the 1 dB down point? Well, it's probably 17.5 or 18, something like that. We actually, in our build manual, we'll put the exact specifications in. It's just not possible to put every little division here. Now, this is where it gets more interesting. So how about 80 ohms? That's what we say is the limit. And you can see it's starting to roll off a little sooner, and quite a bit sooner here. Its 1 dB down point is not really that bad, but if we were to say that really this is effectively is the best of the low end for it, it's more like 25 hertz really. And then it rolls off very sharply. Now, what about 40 ohms? We don't recommend 40 ohms, and at 40 ohms you're not only going to lose low-end performance, but you're going to also lose power, a lot of power, maybe half the power. And that's typical when impedance matching is not correct for the design. You'll see that your frequency response is not as good or really bad, or your power will drop off. And here you can see we're starting to roll off much sooner. We're still very respectable. At this point, we're at about half a dB down. But look at the difference in performance at the minus 1 dB down point. So the minus 1 dB down point is way up here around probably 36, 37, something like that, hertz. Still not terrible for headphones, but the power loss is significant. So, and sonically, even though we have preamps that can drive this power amp easily to maximum output, it doesn't matter. It just doesn't sound that good. And there's a couple of reasons for that. One is our bottom end has dropped off significantly. And you might say, well, who cares about bass frequency response? And I used to be in that camp. I used to be like, I can't really hear it. A lot of recordings don't have low end in the recording to start with. And, and it's tough to really get a system set up so that you've got some really good response down to about 20 hertz is my typical goal. And the answer to that is without the lower frequencies in your music when you're reproducing them in your room or on a pair of headphones, the music misses so much of the cues that are key to underlying what was in the original recording. And the reason for that, of course, is that all the music that you hear in the mid-range is underpinned by the bass frequencies. So what's on the drums, percussion, the acoustic bass, electric bass, those all make a huge difference to how we actually hear music. And it was only after we improved the bottom end of our main system that we really thought we'd arrived. Okay, so hopefully that helps you a little bit to understand why it's very important to impedance, to match, to meet the requirements of the specifications for your piece of gear. So when designers test a piece of gear and release it, they do a lot of bench testing and hopefully a lot of critical listening. We do them in equal measure. We spend about a third of our time actually working on the electrical design, a third of our time critically listening to the product that we're going to release, and a third of our time
testing it every which way we can on
testing
the bench.
it on the bench. Yeah. And in fact, today we just did a square wave test just to make sure that our ears weren't lying. And yeah, they passed the square wave test brilliantly. And in a future episode, maybe we'll do the square wave test because it's a lot of fun. Okay, Charles, you've got a few really interesting tubes that came in.
Yeah, let's clear the deck and we'll be right back.
Okay, Charles, what have you got?
All right, well, this isn't something that's new that's come in recently. We actually have some cases of these guys that are new old stock that are sitting around that I finally have gotten around to testing and clearing and listening to. And this is one of our favorite dual triode preamp tubes. This is the 6N1P EV made by Voskhod. And these are just fantastic sounding tubes.
Now, hang on, it says EB on the label.
Yeah.
In fact, it says 6H1N dash
Let's try and get that on the camera here. Well, of course, that's Russian Cyrillic. So in English, we would call it a 6N1P EV, which is the equivalent of it.
Right. And the EV is the military-industrial version of the 6N1P. And these Voskhod, in fact, I don't think we've ever met a Voskhod tube that we didn't like.
No, they're really nice tubes.
Very well made. Certain factories in the former Soviet Union tended to specialize in certain types of tubes, and Voskhod really made the miniature 9-pin well. They just did an excellent job at it. We use this tube in our very popular rocket preamp kit.
Yep.
And it is a unique sounding preamp tube. It's got a very open sound that is clean, it's clear. It allows you to hear the space around vocals and instruments in a way that very few tubes can accomplish.
Now, this isn't a direct equivalent to something like a 6DG8, although it's very close in terms of that, but I would consider this to be my favorite amongst all those types of tubes. It is just very, very good sounding, and that's why we built our preamp around this tube as the main one.
Okay, so you've got a whole bunch tested and ready to go.
Yeah, and they tested beautifully, matched tightly, and our preamp isn't the only one that uses these. It's popular in a whole bunch of other ones, and for good reason. They're also very, very reliable tubes.
Yeah, and they're reasonably affordable.
Now over here we have something a little bit different. We talked before about how we were getting in some more NEC 6CG7s, also called the 6FQ7. This, of course, is just the 9-pin equivalent of a 6SN7 that came much later.
And it just needs an adapter.
Like one of these guys.
Now be careful. This is actually made for us by MTATA. Be careful. Not all adapters are the same, and you've got to absolutely make sure that the adapter you're choosing can handle the tube type to the circuit type that you're running. So the 6CG7 is about the easiest 9-pin to adapt.
There's nothing weird going on with the heaters. It's pretty much a straight pin-to-pin matchup.
Yeah, and in fact, we've been selling a lot of 6CG7s and a lot of adapters. We were almost sold out of adapters. I think I've got 2 pairs left. We might have to get some more on order soon.
But the neat thing about these guys, so the bunch that we got in, we got in a mix of new, old, stock, and used, and this was in our used pile. And I noticed there's something a little bit different here. We've got these neat little fins at the tops of the heater posts here. And I haven't seen this on any of the other tubes. These were clearly marked as NECs. They have all the NEC features on them, so it must have been some little produced subvariant.
Now, why are we interested in NEC tubes?
Oh, because they were set up by Western Electric. That's why they're interesting. And they're great sounding tubes.
So if you know anything about vintage tubes, the word Western Electric should have you, if you've got something for sale in your area that is compatible with your amp, you probably are already out the door and have forgotten about the video.
Yeah, so these are in the stores used now. Previously, we've only had them in as new old stock, and we only have 1 pair of used ones in this specific subvariant here. So if you're interested in them, only 1 pair. We have nothing else. And they were great sounding. I really enjoyed clearing them. The NEC tubes are really great.
Yeah, and you didn't make a special listing for those, right?
No. So, if you're buying them off the used set and you want the standard one, let me know. If you want this guy, let me know. Whoever asked for them first is going to get them.
Okay, well, what's last, Charles?
That's it. This is the pair.
Oh, you've put out the pair.
We actually haven't had a lot of stuff coming in after our sale here, but we're hoping to restock some more tubes soon.
I thought you actually put the regular variant out.
Nope.
Okay. Well, yeah, and big thank you to everybody who participated in the summer sale. It was a smash.
It blew us away how busy we were, how many orders we had come in.
Yeah, we had 2 extremely busy weekends, and a lot of people were stocking up on their favorite types, and that is a really smart thing to do, especially when you can get a discount. A lot of people ordered quads of power tubes, which is another smart thing to do because, of course, the savings are really big.
And a few people were really smart and ordered quads with spares.
Yeah. And I don't have to say it too many times, do I? If you have a spare for your power quad, it'll extend the lifespan of it for hopefully a number of years, because power tubes just do not last as long as preamp tubes.
And you're never going to have, you're almost never going to have 2 tubes fail at the same time. You're going to have 1 go, and then your 3 tubes are going to be useless without a spare.
Yeah, it's just the way it usually happens. So, and if you do lose 2 power tubes both at the same time, that's a really sure sign that you probably have a problem with the amp. So, and maybe it's just a biasing issue, but anyways, that's a topic for
another episode.
And if you stayed to the very end, here are some discount codes you can use. And there's a secret code that a lot of people grab and costs us a lot of money every year. And I'm glad to see it. It means that you're a viewer or a returning customer. We can reach almost everybody around the world with flat rate $20 shipping. And if your order is $150 or more after discount, the shipping's on us, folks. Stay safe, everyone. This is Jim.
And Charles.
Signing off. Cheers, everyone.